This is lesson 64 of the Quantum Mechanics, a mini lecture series, Eigenstates Part 2. So having talked about what eigenstates and eigenvalues are, now I'm going to get into the nitty-gritty of illustrating the main ideas talked about in the previous video with a simple example. Suppose I have a matrix given by the following. Okay, a 2 by 2 matrix, so 2 columns, 2 rows and 2 columns. And I have an eigenvector given by this. Okay. If I multiply the matrix by the eigenvector, here's what I would get. Okay, so I would get 1 times 1 plus 2 times 1, right? So 1 times 1, here's how you do matrix multiplication. 1 times 1 plus 2 times 1, which is that. That's the first element. Then I'll have 2 times 1 plus 1 times 1. That's the second element, okay? So it basically spits out a column vector, right? So if you do the maths here, 1 times 1 plus 2 times 1, so 1 plus 2 is 3. And then 2 plus 1 is 3. I'll get this. That's the same thing. If I factor out the 3, I'll get this. So the eigenvalue in this case is 3. And the eigenvector remains the same. In other words, when the operator depicted by this matrix here, okay, let's call this O, acts on an eigenvector, acts on the eigenvector in this case, the eigenvector simply gets multiplied by 3. Right, now as an exercise, try and determine the eigenvalue and eigenvector of the following operation. Okay, it's the same process that I've done before. So that's the idea of eigenvalues and eigenvectors.